So we are still solving equations. Now actually this is the big chapter just on solving quadratic equations, and we're going to get to the inequalities as well. So in equations, the moment that you see an equation, you've got to assess what's happening here. So the assessment is, I've got to get rid of that square root. How do I get rid of the square root? By squaring it. But the first rule is, you isolate it, and then it's going to get to negative 5. Then we have to square it, right? And then we've got to say x minus 4 is equal to 25. Are you with me? Which means that x is going to be equal to 29. And then we just not forget to test. Because if we do test, 29 minus 4 is 25, and the square root of 25 is 5. And 5 plus 5 is not 0. So there is no solution. You could have stopped earlier. You could have stopped there. The moment when you had the root equal to negative 5, you should have known there's something wrong. Because it doesn't matter what happens inside here. This is definitely positive. And there's no way that this answer can then become a negative. So if you had stopped there and said no solution, perfect. Okay, you've got to check it out because it's one of the three red lights in maths. The moment your sum has a root in it, you've got to go check for negatives inside that will make it non-real. Let's have a look at the next one. We're going to have the 3x minus 2 equal to x. Isolated first. Those are the rules. Now for today, once you got into the habit of it, you did it all correctly. Isolate the root, get it on one side alone. Then you square, and you mustn't forget to test. But if you're in an exam in a month's time, and I put everything together, you must realize, oh yes, there are rules. Isolate, squaring both sides, and don't forget to test. Because it's not just going to come natural, you've got to study that. Alright, so then after this step, we square it on both sides. There is only one term, so that makes this one an easier level, which is going to be 3x minus 2 equal to x squared. Making this equation a quadratic equation. What was this equation? Linear. Which I didn't have to do much, I just had to take the minus 4 across. But over here, the moment that it's quadratic, you've got to put it equal to 0. On which side? Okay, it doesn't really matter, but we like to, because we want to factorize, get that x squared, the coefficient, as a positive. So if it's a positive, that'll have to become a negative, and a positive again. If you took it all to the left, you'd have negative x squared plus 3x minus 2, and then in any case, you'd have to divide the whole thing by negative to get it to be a positive, alternative technique. But then my two coefficients, 1 and 2, to factorize that will give me 1 times 1 for 1 and 1 times 2 for 2, cross multiplication, to give me negative 3. Both of them have to be a negative. Don't forget to test your answer. So it's going to be x minus 1 and x minus 2, reading from there. X minus 1, x minus 2. Only us know what's going on there. So then we have x is equal to 1 or x is equal to 2. And I'm so happy I go to the next question and forget to test. Now let's test. Can both of them be true?
Yes.
Likely in an exam, one of them is not true because I'm testing if you're testing. So if we go back to the original sum and substitute the x with 1, you can show it for yourself, but I don't want to see it. I just want to know if it's true or not. And if one of them is not true and you didn't test, you're going to lose 1 mark. 1 mark. It's not 10 for the whole substitution and checking it out. So if it's 1 there, 3 times 1 is 3, minus 2 is 1, and the square root of 1 is 1, minus 1 is truly 0. For 2, if it's 2, then it's going to be 6 minus 2 is 4. Square root of 4 is 2, minus 2 is 0. So rarely, but true, both of them are true. So if I did forget to test, I was lucky, because there wasn't one of them that wasn't applicable. Same procedure, we are getting the isolation of the root. we've got x minus 4, and we square both sides. Common error, kids go and say, square the x, square the negative 4. Wrong. It must be the whole side. Even if I time both sides with 2, I time every single term with 2 because it's distributive law of timing. If it's a squaring, it's got to be the whole side, making this a trinomial when you square it. It's a FOIL sum. So if you forget to do that, you're going to get the wrong answer. This will be x plus 2 then, and then I'll just be a little bit lazy and write it out quickly. X minus 4, giving me x squared minus 4x minus 4x or minus 8x immediately. I like it. Plus 16. Whether you add it already or don't, your answer would be simplified. And I again see that I'm busy with a quadratic equation. The rule is get it equal to 0. I'm again putting it on that side, the x squared, because it's already positive. X squared, negative 8x, negative 1 is negative 9x. And the 60 minus the 2 is plus 14. And you've got to be careful there because that you feel it's so easy that you do it so quickly that you make little mistakes. Then we've got factors again of 1 and of 14. That gives me 2 times 7, that'll give me the 9a. Cross multiply to get to negative 9, both have got to be negative. So x minus 2x minus 7. Have you gotten into the habit of this? Is it getting easy now to factorize a trinomial a la James Bond style? So we've got our two answers. X is equal to 7. Either 7 or 2, 2 or 7. Don't forget to test. Was one of them not right?
Yes.
Let's check. So if it was 2, then 2 plus 2 is 4, and root of 4 is 2, and 2 plus 4 is 6. But the x on that side must be 2, so 6 equals 2. Why does it happen? The moment that you throw away the root because of your squaring, you also throw away your restriction. So you've got to enforce it later. That's why you've got a test. Alright, while it's still there, it's enforcing the fact that you can't have a negative. But if it's gone, things happen like this, and it's not the answer that you think it's going to be. The 7, because you have to test both of them. It's not necessarily that just one is an answer. You could have that there's no answer. 7 plus 2 is 9, and square root of 9 is 3. 3 plus 4 is 7. So that's the true answer. Or you can say this is a solution, this is not a solution, but that is perfect. But we need to see it specifically. You can't come after it and say, ma'am, you see, there was actually something there that I said it wasn't. I've got to see if you discarded it or not. So now there are 2 roots. What do I do? One on either side. Okay, because otherwise you're going to have a bracket squared. If I do this bracket square, I'm going to have a middle term that still has roots in there. So mission not accomplished. So I'll get both to one side, which is a silly little sum because now what's happening when I square both sides, they just fall away. And I've got 4 minus 2x equal to x plus 1, which is a what equation? Linear, making it easy to go to get x. Which side do you want to go?
That's right.
Right side is going to be 3x, left side is going to be 3. If you took it to the left, it's going to be minus 3x equal to minus 3. The answer would still be x is equal to 1. That's such a level 1 sum then. It was maybe difficult because of the 2 roots. You just had to know to take them to both to one side, but the rest of it was level 1. Not even quadratic. But don't forget you have to test. So go back and say if this was a 1, then this would be 4 minus 2, which is 2. So that'll be root 2. Do you agree? And then this would be root 2. Root 2 here minus root 2 there is definitely going to give me 1. So this is acceptable. This is working. I'm done. Finished. Done. Guys, you're going to hear me saying this a lot of times. The stuff that we do in class is like we've done like 4 or 5 sums now of that. We are not going to practice this 17 more of them. It's a waste of time. You've got to go home and practice more of them. Okay? Take the exam and practice more of them. because you might get the idea of we just did a few of them, it's not so important. This will be in every test up until June exam, prelim exam, November exam in matric. Every time will be a root sum. So don't get the idea it's not important. We're going quickly through it, you've got to go practice now. Alright, the next part is when we are solving equations, because we're in the equations now. We're done with exponential, although I can never say that because sometimes it creeps in here and there and you've got to get your rules and interact. But if I told you to go solve this equation, what would you do? Equate it to 0, I like it. I'll take it to that side because then it's going to be positive degree. Now solve it. Now if you look at my heading, you'll see why we're not getting any answers, but let's check. Factors of 3 and factors of 12. 1 times 3, 4 times 3 for 12 is going to be 12 and 3, I'm not getting to 7. Let's multiply the other way around. 9 and 4, I'm not getting to 7. Only 1 and 3 can work, eh? 2 and 6, and I'm searching, I'm not getting to 6. I'm not getting there because it doesn't have factors. Now what? Need to. Okay, you need to know this formula of by heart. So you know, what is this? Ax squared plus bx plus c. That's the general standard form. Ax squared plus bx plus c. Now I give you a new tool. If we cannot factorize, it's because there are no rational factors. That's why we need another formula. So the formula is negative b plus minus, not plus minus approximately, it's either plus or it's minus. So the formula says it's two answers actually. The plus minus means I've got an answer completely as it's standing over here with a plus, and completely as it's standing there with a minus. So the one sum will be with a plus, and then I'll do the exact same sum but just with a minus. That's when it becomes plus or minus. So how many answers will there be? 2. And what am I busy with? Quadratic. And usually, how many answers for quadratic? 2. Because this is actually a parabola. And working out what x is actually searching for your x-intercepts. And normally, a parabola has 2 x-intercepts. But can it have 1?
Yes.
For instance. Can it have nothing? If I'm searching for x-intercepts, I can either have 2, I can have 1, I can have nothing. So when I'm looking for answers like this, be prepared. Sometimes there can be 2 answers, sometimes only 1, sometimes no answers, because it's x-intercepts of parabola. That's what you're busy with in quadratic equations. Are you with me? Now to use it is actually very nice, and you guys all know all about substitution. Because that's what it is all about. Looking at the sum, what is the A? A is equal to 3, B is equal to 7, and C? Negative 12, guys, not 12, negative 12. So we're substituting it in, and that's it. Bob's your uncle, and we've got the answer. So we've got negative B plus minus B squared minus 4A and C over 2 times A, and you just have to substitute. So every place that there's a A, there's a 3. So there's the 3, and there's the 3. Every place that there's a B, there's a 7, and it's important that you've got the sign there as well. If it was a minus 7, it had to be minus 7 wherever. And the C over there is negative 12. Now take your calculator and calculate for me the 2 answers here, please. How do I do it? Because, ma'am, I can't put in that plus and that minus. No, you can't. You first got to put in the plus, get me an answer, and then you don't erase the whole thing on your calculator. You just go back and make it a minus. I need the answer from you guys, please.
Negative 7 plus
Square root?
square root 193
193. Is that it?
over all over 6.
All over 6. So then I'm almost certain the other answer was? It's just the way that it works. Alright, what type of an answer is this? Are these rational answers?
No.
Because they've got roots in it. They are irrational. So the moment I don't have factors, I don't have rational factors, I don't have rational answers, I should have irrational answers. And this is the actual purpose of the quadratic formula. But can I use it even if it has factors? Yeah. Then it was just quicker to do our little James Bond technique than doing this, because it does take 10 seconds more. But if you can't factorize those things, you can always go and see the formula. So if you substitute it with the formula, you got your two answers. And then I can ask you something like, what is the nature of these answers? That's exactly what I just asked you. What type of answers are this? The nature of the roots, new words. The nature of the x-intercepts. What type of x-intercepts are they? Then I want to know that they are, first of all, it's real. Because there are answers. Sometimes you're going to get an answer with a negative inside the square root, and then the answer will be non-real. But there's answers, so they are real. They are irrational, so I write the little Q with the little accent there. Irrational. If it worked out that it wasn't a root, then it would have been rational, and then actually you should have been able to do it with factorizing. But it's fine if you use another technique. But this is actually there if it doesn't have factors. If you want to use it even though it has factors, it's fine. And then the last thing is the whole story about one answer, two answer, no answer. The last thing I'm going to say, they have unequal roots. Now this is a whole story on its own, and I'm going to bring it in gradually for you. Those three things are always what you're going to answer me when I ask you what's the nature of the roots. Is it real or non-real? Well, if it's non-real, then full stop, it doesn't have answers. But if it's real, it can either have rational or irrational answers. And the unequal story is there are two. There are two answers. Meaning on this graph, I'll have 1, 2, x-intercepts. That's all that it means. It's just wording that they like in mathematics. You can't say, and there are two, you've got to say they've got unequal roots. Okay, but that's a little bit extra. For today, I'm focusing on if you are using the formula to get to the answer. What are these answers actually? They are x-intercepts. So if I'm talking about nature of roots, I want to know it doesn't have, non-real doesn't have, real does. And those two answers. And then also the answer, and we'll do it in the next example. This answer can be written as a decimal. And you'll do that when I ask you round it off to 2 decimals or leave it in simplest surd form. The calculator leaves it in simplest surd form. If I want decimals, you go SD. And you give it to me like I ask you.